I think now you understand what I need, and I appreciate you doing that for me.
Yeah,
And
you're
others.
welcome.
Ray Allen's been asking for it too.
Yes, I've got this thing of yours.
Okay,
Okay,
thank you.
This
how's
is
things?
your adapter that you made for the micro SD. So
Oh,
I'll be on
good.
that pretty soon.
Okay, excellent. And it's there is, and I just mentioned Ray Allen. He managed a port of FSRW that seems to be working so far. I had to touch up a little thing because there was a an error between what it was returning from the mount method and what it was actually doing. But I sorted that
Okay, good. Thanks, John and Chip. Let's start, and we'll get back to the
out by
slides.
in the smart pens. And
Okay, I just want to make sure my audio is working. Someone get me.
meeting with people there, a friend of mine who I've done a lot of propeller work for has said, has Parallax gotten around to doing a multi-file SD system yet? Because he does a lot of audio-based products and he needs to have a background audio file playing while other plays on top of that.
Right.
So he
Okay.
needs at least two files.
Got it.
Okay, thanks, guys. Let's start our meeting. We'll come back to this too. We have time.
All right.
So, is my audio okay?
Yes.
Thanks. Um, Zoom is choosing between a number of different microphones. Okay, welcome to today, December 11th, and around 2 o'clock today, Terry's going to show up. It's currently 1 p.m. Pacific, so he's got a work obligation, will be a little bit late, but he's going to show us this Blitzen 24 controller board in action, I think, where he lights up a big property of his in Tennessee with all kinds of different lights. So that'll be cool. We've seen this before, but maybe 24 means he's on version 24. I don't know what it means, but he's been working on this for a long time. So that'll be cool. So he'll be here in 1 hour. Okay, so prior to that, what I have in mind is the following. Want to have give Chip some time to talk about his latest thread on the forums for the multitasking added
I
dispense.
thought it was about C file APIs.
If you want to go there.
No, no, go ahead.
So you're going to do some sharing after I get through a little bit of housekeeping here. Let's talk about January 2 and then going forward. So next month, we will have a presentation from Chris Carroll on the Fishboard, which is a Propeller One application that is either at sea or in hatcheries where they're measuring and weighing fish. So it's pretty cool. Um, he's one of those people who's made a product that he's been, selling for many years and using, and we haven't heard much from him until he asks for a support question. And then I jump in and say, "What are you doing? Can we talk about it?" And so I traded him some robots for a presentation. So expect
Ah,
him in January. Does that sound good?
yep.
Okay, cool. And I think that'll probably be half an hour thing. So beyond January, one thing I have in mind is Eric Smith. We've had a customer ask for Eric to show interaction in flex prop between C and spin. So we have one customer too who developed some applications in C and they're using spin. I think for, I don't know how it's sorted out, but we would like to see more on this. So I've asked him to come talk about that, which might be January or February. But beyond that, we don't have anything. And it's always fun, easier for me to kind of lay out some sort of schedule where we have something to talk about. So if you've got anything to talk about, the project, um, we can do that. It can be as short as 15 minutes, or it can be an hour. Like a lot of times when Johnny Mac talks, he gets into the code and really shows us a lot of what he's doing. Some people just keep it on, surface, like the fishboard might be. But whatever, if you want to share something, please contact me so I can get you on the calendar.
Ken, I could share that game piece that I sent a picture to you and Chip because by January I'll be completely finished with the code, and some of it will be interesting, I think, to general users.
All right, gotcha. How about if we do it for February?
That'd be even better.
Yeah, give you some time. And us too. Cool. So you're down. So then we're more into like March, April, May. Anyone's got something, let me know. Other things that have just been shared recently, if you get my spam, maybe you saw this. I'll put this in in the chat right now. I had applied some improvements made to the WX Wi-Fi SIP module by Michael, which make it really easy to program the Propeller One over Wi-Fi. So basically, you just, although my video is 7 minutes, that's because I've got some marketing gobbledygook in there. It's really simple. You just configure the module with a spin program, and then it's on your wireless router, and then it becomes a programming port. And I've used these tools through their development at various stages, and I can say now this thing really works reliably. It's cool. So you can watch my video for details, but everything's available online, and then you can pick yourself up a flip and a WX module as well and try it. I'm using Spin Tools IDE, which is also neat, and it runs on everything. And it added the support for Propeller One wireless programming just last week, and I think he's already got Propeller 2 support in there. So pretty cool stuff. And you can switch between the COM port and the wireless one with the board hooked up on the COM port. So for someone like me, that's really cool, especially with robot stuff and my things that walk away or roll away. You know, this is great. Also, we've had a lot of chitter chatter, and just before we turned on the recording, John was talking to Chip about getting an SD card support for a Propeller image so that customers can throw a new SD card into their application and then have the latest firmware. And I've had other customers, one of them who's here, also John Huffman, who put hardware out at various customer locations, and they want their customers to be able to reprogram. And we have one solution. I know there are a lot of little things out there, but we would like to work towards getting something that runs on Windows, Mac, and Linux that is just a binary grab a file and load it and have it confirmed type of tool that a field technician could use. So this is a good system right now. It's really easy to use Propellant. And you can download this way, but it works only under Windows. So we've got P1, P2, and 3 operating systems. And I would really like to have a system that can be compiled on all those platforms that uses whatever things we provide. I don't even know what it takes from Parallax, but I'm working with Jeff and Chip to clarify that so we could put out the pieces and see if we can get some community members to help us with this. Because they're already doing good tools. Anybody else need to have customers reprogram things?
Hey, Eric is saying something.
Oh, Eric.
Hi, Ken. Can you hear me?
Yeah, just a little bit quiet.
There's a tool called Propeller that, I mean, it's a command line tool, so it's not a nice GUI, but it does work for P1, P2, and all the operating systems. I think originally it was a Parallax tool, although I've been maintaining a fork of it for a while.
Eric, don't you also support the over Wi-Fi as well with that?
Yes, it does.
So Propeller does all that, and is that accessible through FlexProp?
Yes, it's used by FlexProp when you're doing Wi-Fi downloads.
Oh.
And it's in the installation package, so it's something we can use.
Okay, so Propeller is kind of the lower level pieces of this, and maybe it could be turned into something that is graphical, file open, binary, and then identify the system and then download.
Or even potentially even drag and drop on the back end of one of your pieces.
Yeah.
Yeah, that's easy.
Okay, well, that's good. I didn't know that. And through a number of emails inside Parallax, this didn't come up either. That's why we're here. Super. Okay, who should I talk to
Eric,
about that?
That's what I'm doing behind Visual Studio as well, is I'm using the Load P2 and Prop Loader.
And who's the origin of Prop Loader? Is it Parallax?
Uh, David Betts, I think, wrote it, but there was a Parallax repository for it, so it may have been under contract. I can't remember.
Cool.
It's from a long time ago.
Okay, I'll dig around for that and see what exists then.
Yeah, I've got a fork of it on my GitHub repo
Okay.
that's probably a little bit more up to date in terms of P2 support.
And hey, since I found you, can you talk about FlexProp C and spin interaction in like January or February?
Yeah, I think so. Sorry, I just saw your email. I've been kind of busy all day, but yeah, I'm sure we can do something.
Cool. Well, people always ask me, hey, do you know a good engineer who can help me with a project? And good engineers are always busy. So the answer is usually no, I don't know a good engineer who can help people with their projects. So I'm glad you're busy. Okay, Chip, you want to talk about multitasking
Sure.
and spin two?
Yeah.
Right.
So lately I had this idea that it would be really nice. I thought of this in the past to be able to do some kind of multitasking and spin. Because for where I'd like to take the applications in the future, I'd like to make development platforms where the user can compose a lot of really simple programs to take care of stuff. Because you're either, the way of thinking in all this tech stuff is you can do like we do in programming and think in a single threaded model, right? Where everything happens in sequence and you have to maintain some state information along the way. And it's kind of hard to think about. It's like they're like different function domains, like polar versus Cartesian coordinates or something. The other way, like the extreme other way, is where you have like a PLC programming where everything happens in a giant loop and all kinds of state is maintained, and you have to, maintain state stuff. So it demands you think a certain way about things. But I thought it was most natural that people kind of think about, they compartmentalize their problems. I think the human brain wants to do this so that you just think about things in pieces. Like I need kind of like one little program to just do this. I want one program to go do that. And then you can coordinate with variables, which is kind of the idea with the cogs. But there's a lot of stuff that could happen that's like kind of low bandwidth that would just be okay with like spin multitasking, spin level multitasking, where you can have them fork off all kinds of little tasks and have them run. And you can start and stop those tasks. They can stop themselves. You can also pause them so that you can kick them off again without having to go through the whole procedure of setting them up and pointing them towards a stack to work in. You can just stall them. So the stall business, I figured would be nice to be able to work with like assembly language interrupt programs so that they can be completely asynchronous to the spin interpreter, because the spin interpreter is too stateful to just randomly interrupt and have it go do something else, because it could be in the middle of like a say like a giant indexed structure manipulation with some bit field, and there's a lot of state information strewn around. Sometimes need to which source code level, right? Not necessarily the bytecode level, but at the source code level, the statefulness is reduced to like what are basically 8 contiguous registers in the interpreter, which can be like, pushed, and then the pointer can be saved. You can go grab another pointer, pop a context, and then start up again. And I'll show you the code that does that. But in the end, what it lets you do, it looks kind of like, let me share my screen here. And this is implemented already in V47, which is on the OBEX. All right, let's see. Okay, here we go. Okay, portion of screen. Okay, let's see here. Let me pull up my, okay. So here's a program that is doing some like some task switching. The mechanism for launching a new task, and by the way, now your main program is just kind of from the perspective of all this machinery, it's just a task. right? So the main program that your spin runs isn't ever going to be any different than it's behaved before, but you can kick off new tasks where you start kind of time dividing, and you control when the switch points are, but you time divide that spin cog's the work that it does. So to start up a new task, and Rayman had the good idea of I had this called, it was like called task init, because why don't you call it task spin? So it's a corollary to cog spin, where you give it like the cog number, the method that you want to start, and then some stack space, and it starts a whole cog, right? But this just starts a task. So it splits off a new task within the current spin cog. And then every time the interpreter sees a task next instruction, it switches over to the next available task. That is the task that's on and it's not halted. It switches and runs that until it encounters the task next instruction somewhere in that. So in this case, we're gonna launch like 16 of these guys right here. And what they're gonna do is they're just gonna like print out their task ID, which is kind of like cog ID. This is another corollary to cogs. Cog ID, task ID is going to be 0 through 31, because there's 32 tasks, with the initial task being task 0. But once a task, like once task 0, that's your core task. Once it starts something off, it's all peer-to-peer. It can like end its own task, but the other tasks will carry on, and it'll really be no different. Task 0, it's all peer-to-peer. There's no priority, or no task has any special quality. It's all just kind of the same thing. So it's going to print out its task ID, and then it's going to print out its status. So the task check, it's kind of like cog check. Task check, it's like 0 is that task is off, it's not allocated, and 1 is it's allocated and it's running, and 2 is it's allocated but it is halted at the moment. So you have 0, 1, and 2 feedback from these things. So what this thing's just going to do, it's going to, let's see, it toggles the pin. So it's given a parameter I, so it toggles pin 32 plus ID. ID is what it got. So then what it's going to do, it's going to do some number of tasks next. So it's just going to keep switching out. So each one of these is going to take a different amount of time effectively, right? Because they're all switching out. But they're repeating their task switch so many times. It kind of creates a time constant of sorts. Anyway, so it starts off these 16 tasks, and then it randomly like does a task halt on one of the 16, being numbers 1 through 16. That's what this math assures here. They're getting 1 through 16, not 0. Anyway, so it halts a task, and then it continues the task. And then I had to make a special like wait instruction, because we can't just do a wait milliseconds, because it's going to hog up everything, right? And it's never going to switch out. Nothing else will execute. So it has to figure out like a time marker. So it computes a time marker at some point in the future. So it's milliseconds times X. And then what it does is it just keeps repeating this. Is it time yet? And keep looping and doing task next if it's not time. So it keeps switching to the other tasks while it's waiting the 200 milliseconds. So when this thing runs, let me get this window up here. I'll start it over again. I'm just going to pause it here. So the first thing it does, it initialized all those tasks, and each one reported his ID and his status 1 is running. And then it's going and reporting which task is stalled. Let's see, is that what it's, yeah, 2, 1, 2, 1. So it stalls a task. It randomly picks a task. That's why it goes 9, 3, 2, 1, 14. It stalls it, and then it runs it again, and it's showing indeed you're getting a 2 when it's stalled, you're getting, or halted, you're getting a 1 when it's back to running. And then eventually they all time out, because this down here eventually runs out, right? So eventually all the tasks, when a task actually runs all the way out, it kind of kills itself. It says, well, I'm done. There's nowhere for me to return to. So the last return in the stack is to the thing that cuts the task off. So it does a stop on that task. So all these tasks that used to be running now are not running. So this isn't like, this is just something I did for making sure it works. It's not like a practical example of what a customer would do with it. But the point is that you can start up now tasks, kind of like cogs. And as long as everyone in the circle keeps executing these instructions, it'll switch over and go to the next task. And eventually it round robins all the way around. And then like in this case, let's see, task. Oh, well, this is where it's doing all the task switching in this task 0. But eventually it comes back and executes the instruction after the task next. So task next is like, take a break, go run everybody else, and then when you come back, we'll run my next instruction. So this keeps everything going. And because it's cooperative, you don't have any worries about locks or anything. Like if you're doing something critical that you don't want interrupted, you just do it all and then do the task next to switch out. So it's very safe that way. And everybody, of course, has their own, state variables in their top level method that was started off. They all share the common variables. So it's kind of like starting up cogs, but it just time divides the activity of the spin cog.
Skippy, can I ask questions that others would be afraid to ask?
Any questions? I just talked a lot.
Yeah, I got a couple. I don't know if my connection's stable enough, but
So if we define a spin task chip, we really decide as if it was just running in its own code.
Right.
If we want to keep it running. I think that's why that program I sent you this morning wasn't working. It just occurred to me, so I'm going to see if I can fix that.
Okay, I haven't looked at my email yet.
Chip, a question along the same lines that John's talking about here. If the method were to end, can that be an automatic halt of the task?
Well, better than that, it does a task stop, which is like a cog stop.
Yes.
Same thing a cog would do. It just stops.
So it won't repeat unless there's a repeat loop. Otherwise, it's a single execution and it's forever taken out of the loop.
Right.
Okay.
Yeah, it runs its course and it exhausts itself. So see this thing up here, this new task? That can be 0 through 31, or if it's -1, which this constant new task is, that means just go start up the first available one.
Nice.
And then so those things can run out. So what you can, and this thing returns either -1 if it couldn't do it, or the task number. So you could actually put like task things, you could be allocating tasks in a loop. And then when you were getting -1 back, that means you filled up, so wait a while, or just keep doing it. But then you could know that one, keep repeating until you get that one launched.
I really like the parallel to the cog allocation, the task allocation. Very nice.
It works. Yeah, the syntax is identical. We have the same things. We have cog stop, we have task stop, but we also have task halt and task continue. So any task can halt or continue any other task, but because those bits are actually just in a 32-bit register, which has a symbol that's in the compiler that you can use in your code, you can have like a PASM interrupt service routine on a timer actually be restarting tasks. So if you wanted some task to run like every millisecond, you can just clear the halt bit from assembly language on an asynchronous interrupt. And because this is happening asynchronously, it winds up synchronous with the interpreter, because the interpreter doesn't use it until it gets to the point where it's looking for it. And then it goes based on, is it halted or is it continuing?
Chip, I have a question. Are these task commands spin commands?
Yes.
So they're already in the language.
Yeah, if you go get 47, it's all in there. And let's see, I'll show you the commands. Okay, let's see. Let me move this right here. This is the, okay, here we go. So this is the whole thing about V47 right here. So these are all the commands. Here's task spin to start it up. Whoop. So this task spin starts it, and then task next switches. Task stop will stop it, and then halt. A task can halt itself, which is like putting itself to sleep. And then when it gets unhalted, it just picks up again at the next instruction. So a task can halt itself, but it can't really continue itself because it's already asleep. But you could have one task continue another task, or halt another task, or you could have like an assembly language timer program interrupt and just clear that halt bit, and then it'll be like doing a task continue. And then task check gives you the status, and task ID says, who am I? Like, am I 0 through 31? So that's the whole set of instructions that are relating to this task setup.
Hey, Chip,
Yeah.
I got my little Blinky demo working based on putting repeats in there. Can I show it so we can go through it and you can say, hey, no, you need to do that?
Yeah, absolutely. Yeah. Let me stop sharing here. Yeah, go ahead.
Let me find the share button.
You have 47 running, or will we just edit
Yes.
the code and say,
No. Yep.
okay.
Well, and I'll bridge on what Ken and you said. So I'm running 47 through Spin Tools IDE.
Okay.
With PST as my output. So I've got everybody covered.
Okay.
Where's the share button? Oh, there it is.
Now, Massimo, he has not integrated 47 yet into his system, right?
No, but he has implemented external tools. So
Right.
I can edit in Spin Tools and I can compile with Peanut.
Oh, okay. Okay. There you go.
So I need screen, right? Yeah, it's not just one app. Okay, can everybody see my screen? Should be Spin Tools IDE.
Yep.
Yes.
Okay. So these are probably too big, but these were based on what you're saying. So what's going on here for everybody else, and Chip, when you read your email, is that I want to run a simple real-time clock, and that's a foreground thing. And I'm using pole count because, as you pointed out, wait count will stall everything. So that's running my foreground 1 second thing to do my clock. This displays the clock. And then again, I'm old and I was raised in school, blink LEDs first. So
Right.
here's toggling one of the LEDs on the eval, which is what I've got running now. And here is toggle the other one, but at a different than 50% duty cycle rate. So those I call task 0 and task 1, and they're started this way. Is this strictly necessary after you define a task?
No. No, I mean, you can, as long as it happens at some point.
Yeah. Well, that's what I'm
Yeah.
saying, because up here in the main loop, then, since it's mostly not going to be updating the clock, it's constantly doing this. Now, I
Right.
did a version of your wait MS. This is my version because I have a constant for those ticks. I don't have to do a division there.
Right.
So this seems to work. I mean, it's been running for a couple of minutes now, but is there anything that I should have done differently?
No, that
Okay.
looks fine. Yeah, this is kind of what I did, but it's using 2 tasks, right?
Right.
Oh,
Right. Yeah, because I wanted to see something different and I wanted to see something in the world
Right.
on the clock. So if I bring up my window, well, and I'll just show everybody what I was talking about. This line, this is if I go to edit preferences, in Spin Tools IDE, there's a tools section. And so I have one called Peanut RAM that runs Peanut with the file that I have in the editor tab, and it uses TAC-R to compile it and run in RAM. Marco just added this so that I don't have to worry about saving. It'll just automatically save for me. If it's an external tool, you have to save the file. So that's really nice. On PST, since I'm just running PST, I have it clicked to none because the file doesn't matter.
Right.
And I can get rid of that. So with these tools now, what Marco has, I asked and he's agreed to. So these correspond to Alt 1, Alt 2, Alt 3, Alt 4, Alt 5. From the keyboard. He's going to add tool buttons up there later. But it's still quite nice. So now if I have the program, even though you can see here, you see these little red blobs, Those
Yep.
indicate errors, but that's because internally he's using his compiler, which doesn't
Right.
know anything about tasks. In fact,
Oh,
if I comment out all of the lines that say anything to do with tasks, it compiles fine with his internal compiler.
got it.
So now if I do Alt 1, it will download. It just did. And then if I do Alt 5, it'll bring up PST. And in my case, I have it wait for a button, and now it's running a clock. And I have P56, toggling every 333 milliseconds. And then the other one is toggling 250 on, 250 off.
John, a question.
Nice.
Yes, go ahead, Stephen.
Can you scroll to where you were starting the tasks?
Yep.
You have task next in there. Was that necessary? Why is that necessary?
Well, that's why I was asking Chip. It was strictly necessary. He said no. So I'm going to take this out because
Yeah, you could get rid of both of them because once
once it comes back up to the main loop, it's doing that all the time right there.
yeah, and the task
Ah,
switcher,
okay.
when a task runs out and it goes, oh, there's nothing left here, I'm going to see if there's another task, and if so, I'll switch away to that. So it takes that task away because it's done, and then it kicks off the next task. So it's kind of has all these little boundary things covered with like kind of what you'd expect as behavior.
Good.
And for those that don't haven't used this now, it's been in P2 for a long time. I just didn't know about it until recently. This is a very useful instruction, poll count, because it's like wait count, but it returns true if you're at or went past your target.
I forgot about that. I should have used that one.
It's real. Well, I thought it might be useful for this kind of thing, but I used it. I have a game piece, and I think I put a picture up in the forums that we just showed in Florida, and it has a tower that is 15 pixels tall, and the rate at which those pixels change is a user setting. So or we could get an smooth rise from top to bottom if somebody captures the tower. So any of you want to go to the hard point, it by his reaction, and
Oh, totally. I had just completely forgetting that did that, but I couldn't find it. But it was called poll count. So I changed it to repeat until poll count.
oh, he in the delay.
Poll count.
Yeah.
Yes.
Forums. So anybody that do you have to, and maybe it was a mistake on my part, but it worked, even though the compiler I'm using is V47.
It might blow up someone's older code.
Okay. All right.
Task spin, task stop.
Yeah. All of the task. Yeah. The task. There's everybody where we've got spin tools, chips, peanut to do the compiling, or sorry, PST, because I just terminal inside of Spintool's IDE. I just don't like it as much cooperatively. That's a nice thing. I mean, Marco has been really gracious implementing those things. I mean, he created he liked Propeller tool, but he preferred to run on Linux. So he made, so it's between this and what Steven's doing and what Eric's doing, we collectively and with help from Parallax get libraries and everything in Propeller. Because I was just I had a meeting at in Florida with a friend and was telling him about the P2, and he had no idea the capabilities. And people, the rest of the world has. Anyway, I'll stop
Good.
now. Stop sharing.
Another question, Chip, maybe. When I've dealt with multitasking, I guess you call it, usually there's a common operation, which is I need to like make a queue between two threads or whatever, and then I need to like post a message to a queue, and the queue wakes up the other thread, for example. Or like there's many threads can post to one processing thread. So the kinds of the things that I usually are involved here are like I think your concept would be to like to if I need to tell some thread to be ready, for example, maybe it goes into a halt state, and then when I post to the queue, I'm guessing what I would do would be something like tell
Task
that
continue.
task continue, and that way that task will when it gets around to it, that one will be executed, right?
That's right. Yeah.
Okay.
Yeah. Yeah. So you can design all that stuff at that level. You could do lots of things that way. I don't have any kind of like task prioritizing or because I started thinking about it and it starts to get so complex. And usually you're pushing sand when you do stuff like that because you can always improve one case at the detriment of others. And it's like chasing your tail and you go crazy. So at this point, I figured it's cleaner just to not have that. Just keep your tasks all short enough before they do another task in it that you're not going to cause anyone a headache. And the task next instruction is just one bytecode. So you just throw those single bytecodes throughout at those interstitial points in your program where you don't mind if it takes off, and you can keep the rate pretty high.
Usually called yield, I think. Yeah. And yeah, like yield.
I didn't, I thought I saw that word yield, but then it seemed like it was being used for other stuff and I couldn't figure out. So, but yeah, I like the idea of yield, but I didn't, everything to do with task starts with TASK, so it's not like so it's kind of the instructions by the first word in their name.
Yeah, it's a kind of like a library set of functions of the library. Yeah.
Task next to me seems wordy. Maybe task SW would be better. Or just switch but anyway.
Task next makes it really clear that this is a round robin.
Stay wordy, Chip.
Same what?
Stay wordy, please.
Okay, yeah. Verbosity is good when you come back later.
Yeah.
You could abbreviate it, Chip, to say task next NXT instead of NEXT. You could abbreviate it. Yeah.
Yeah, we could do it's just next right now, but yeah, we could make it next T or even next next is already a keyword for use in loops.
Yeah.
All right.
Let's leave it be.
Leave it be.
I'm with Stephen on that. Keep it verbose, keep it long.
Keep it readable.
It helps in troubleshooting.
There is no case of just a set of parentheses being used for anything else yet. What if we just use a set of parentheses?
Stop it.
How about no? Let's make code readable again.
Please.
Yeah.
Chip, I have a question.
Yeah.
For those that may not understand it as well as those who do, like let's rewind like a month or so and there's no task switching in spin 2. Would this be like make a situation easier where I would have had say like 16 methods running in a cog doing different things and I'm trying to figure out when to go to the next one and how to get there under different conditions? Like what kind of situation would this make easier that I used to.
Okay. So let's say you have all these different things going on. Well, they're not always locked in step with each other, right? They're all in different states in different little modes. So you want to allow these little programs, these separate tasks to run and be in their own states because they're not always at one point of another uh, uh, task, or they at the same point they are in some other task. They're not in lockstep. It allows everything to just kind of run freely and timeshare so that you don't have to be worried about this, exactly what state, because there's a lot of ways to remember state. You can just store state in variables and have a loop like a PLC does, but that requires like a certain discipline and thinking. But we're much more inclined to want to say, well, do this and then do this and then wait for this and then do this. But your other tasks are on all different, they're in their own little loops doing their own, decision making trees, and you can't correlate them all. They don't all go together. They need to be kind of separate animals and have their own lives.
So they're running concurrent within a task.
Well,
Within
they're time sliced, yeah.
Time sliced.
Well, not time slices. It means like preemptive, but they're each getting a little bit of time as each one yields to the next.
So you wouldn't want to put a lot of like time consuming things in a task. It's more for like doing a calculation or
yeah, you want to
LED on like, or a clock like John showed.
Yeah, like if you want to wait, yield by doing task next while you're waiting so that you keep everybody else running. It's just like being a good citizen, I guess.
Does everybody understand that?
Mm-hmm. Makes good sense the way it's written.
How about everybody else? Excluding you.
I want to show one little bit of this code I thought turned out really cool. Let me go to the interpreter here. Let's see, let me get to the task section. Oh, wait, I put it all at the bottom. Okay. I'll share my screen.
Johnny Mac, are you going to post before you go, Chip, Johnny Mac, can you post that clock example?
Yes, I will, Ken.
That's awesome. Thanks.
Okay, this right here is the task next code, right? Now, never mind this top line. This is because sometimes I have something on the stack I need to pop because I came in on a multi-byte bytecode because I don't have enough room in the lookup table to hold everything. So I have this 1 bytecode that means go grab another byte and then use it as an index to go look up a word and then run it. So by the time it gets into that line, it's already got something on the stack that it sometimes needs to pop. So, oh, thanks. Did it work okay? Did they give you the tire back? $20. Oh, awesome. Okay, thank you. One of our tractor tires went flat, and anyway, we put a plug in it, but it turns out it had an inner tube, so it just completely needed to be redone. So, okay, so anyway, never mind that first instruction. So the meet starts at task next H, right? So all this down here. So this is all that happens when you do a task switch. But before I show you this, let me go way up here and just show you the state variables. So right here, you see these things here? From here to here, between instructions as you write them in spin, all context is consolidated to these registers. So you have the program base, which is like the OBJ base. You have your variable base, your D base, which is the base of your current working stack. And then you have these mreceive and msend because those carry on the stack. And then W is just a general purpose. But what I do is I stick the program counter into W. Decall is like a link register that lets you go when you do a return. You got to know, where do I go back to that I was before? So that gets stored there. And then X is always the top of stack. So by putting the program counter into W, you can then do a set Q and a write long, and you can store the entire state of the interpreter. So when I go back to here again, let's see, right here, here's what it does. So it comes in here, right? And here it puts into W, it puts the program counter into W from the bytecode thing. And So it just pushes those 8 things right onto the working stack. Just boom, push it. Then it looks up the task number, and then it writes the stack pointer, which is pointer A, right? Which is now incremented by 8 because of that. So it stores that in the task list. Then it picks the next task, which is right here. So what it does, it gets the task enabled, which is like a 32-bit of ones tasks that are enabled, and then it ends it with the not of task halt. So it cancels certain bits that are halted. Now it should always fall through, but in case all tasks are halted and there's nowhere to go right now because everything is halted, then I had to put this thing in here, like, this shouldn't happen under normal programming, but someone could write an application where it would need to loop, right? Because there's nothing to do yet. Wait for something to do. So what would happen is a PASM interrupt service routine would write to task halt, and suddenly this thing would be able to fall through because he would clear a bit of a halted task and then it would fall through. Now this little thing here is what picks the next task, but I'll come back to that. So let's say after we pick the next task, then what we do is we look up the pointer A from that context, we reload, we pop those 8 state registers, right? Then we kick off the interpreter again by W held the program counter, so we start the X byte thing up again by doing a read fast at that address. So now suddenly, boom, we're in the next task. But this little business here, this was really, what this thing does is it looks in all the bits and finds the next one, but it keeps it running. And so I would never have written this code at first because it doesn't make any sense. But what I did is I coded it the way that looked logical, right? So it's like, okay, I have all these bits. I want to find the next most significant one. That's going to be my new task. So then I'm going to next time scan from right below that bit, and I'm going to look down again. So due to so it rotates X tasks. It code result and adds it to the other, deterministically. Is this guy set? No, increment the counter. I mean, that's how it's this way. So this in 8 clocks determinately picks the, and then it just does the grabs that pointer A, pops that something not that complicated. And I had to kind of rearrange some of these state variables so that I could do them all in one whack, so that I could, have one block to push. Builds from the last register in the open space, which is 11F, it builds downward towards 100. Okay, but it only gets as deep as your tasks are for the number of tasks that you have. So if you're only running 3 tasks, it's only going to use 11F, 11E, and 11D. So I had it so it doesn't encroach all the way into those 32 registers. So you can use as much of those as the task thing doesn't need. But I wanted those in register space so they were very quick to grab, and I didn't have to set up like a buffer out in memory to do read long and write longs with. Anyway, so that's how the task switching works. And then I've got stuff here like this little bit. It handles the task stopping, halting, continuing, and checking. And this is like kind of crazy code but it like if a task stops and it stops that task, but then it looks and sees, okay, is there any task left? Not that's necessarily continued, but simply enabled. If there's any enabled tasks left, then it switches over to that one, which, it's going to run that task or wait for it to unhalt if it's halted. But then the thing is, if there were no more tasks and it hit a task stop, or simply that top method ran out and there's nothing left to do, then it actually stops the cog. dead. So just now at this point, free up the whole cog. So these little support instructions. Here's the task ID. It just gets, the task ID just tells you, it just reports back the task num. Oh, that's probably not, I don't think I need that and. Oh, I need that and there because I not this. Because in order to get it to build downward, and because the encode instruction works from the MSB, the user interface is all backwards, right? When you say task 0, it's going to hardware-wise go task 31. But that's all hidden. No one ever sees that happen. All you know is that you got tasks 0 through 31, and they build downward from the last register. But that's why I had to have that. And then here's the task switcher. And that's the entire task system right there. It's not that complicated. All right, I'll stop this sharing here. Any questions or comments about that?
How long did it take you to figure all that out?
A couple days. That 4 instruction sequence that switched tasks, that was like a 2-day thing in itself. Because I first figured out, what do I need to do? How do I code it? And then I started realizing, like, oh, well, if I make it so it's, because I had it encoding from the LSB, not the MSB. But I figured if I could exploit the encode instruction, then I could make it really fast. And so the way it kind of algebraically reduced, I never could have written those 4, really three core instructions: the rotate right, x comma task num, and then encode it, and then add the result back into task num. That doesn't, you can't look at that. It doesn't make any sense, but it's real because I coded it first with a lot of code. Then I realized, oh, it can be just this. But I wouldn't have started there because it doesn't make any sense to look at. But it works.
As long as it works.
Yeah, it works, and it's fast. And the halting is just, to support halts is just another 2 clock instruction. You just and not X with task halt bits, and it incorporates it right into the next task seeker. So it doesn't, it's all, like, I don't think it could be any faster, and I got everything oriented in memory as efficiently as it can be. So the whole task switch doesn't take much time at all. Just like maybe 16, I don't know, maybe 32 clocks or something. So 100 nanoseconds at 320 megahertz.
Question, do you have to have each task in a separate cog?
No, the way this thing works is it subdivides a single cog with many tasks. So you can have 8 cogs, each running 32 tasks.
Wow.
Not that that would be like wholly practical, because I figured that for what I kind of want to do in the future, I'll have some cogs that are just doing hard real-time stuff continuously without interruption, right on schedule. But then they'll report data and communicate data at like much lower frame rates that you could have tasks deal with.
So in simple cases, this will be easier to implement probably than a state machine.
Yes. State machines are so hard because it's like a reversal of paradigm in some cases. And the way how things get implemented can make it way easier or way harder to implement. Implementation is like having some flexibility with how you implement solutions can make things way simpler. I wish I knew like the ultimate recipe for simplicity, but I don't know what that is. But I know that in some cases, some things are definitely better than others. But if I had the whole recipe, I would just make like a basic stamp 2025 that would, do everything right like someone's brain would want it to, and it would be very powerful. But I don't really have the mental recipe of that, but I'm trying to get it. But I think that having task switching enables those kind of things.
Let AI do it.
Yeah, I guess Ada is not here at the moment. Ada does not like AI, but I did use AI yesterday because I was implementing a simple preprocessor, which is a subset of what everyone else has done. I'm just going to do the if def and end def, else if, and then the else and end if. and then define and undefined. That's it. Just the basics, right? So but it winds up being a little state machine. It's not very complicated, but it's so hard to think about. So I had to go, okay, within each of these little scopes, you have not yet figured out, already figured out, which means it's dead now, or it's active at the moment. And so I asked AI, like, can you come up with 3 words that can, like, because I couldn't figure out how to name my variable so that when I look at my own code, it makes any sense, right? It was really difficult. So I asked AI, and it gave me like 3 different solutions of like 3 single word terms. It's like, here's from this perspective, here's from a functional perspective, here's from a procedural perspective. So I kind of picked a hybrid of what it gave me. And so I now have like, you could do like past, present, and future. I think that's maybe what I settled with is past. Past means it's already resolved, so any else if or else isn't going to do anything. Future means it hasn't been resolved yet, so an else or an else if could do it. And then present is like, I think I used active or something. That means it's on right now. You know, we're in the active state. So I had to have these 3 states, but it was so hard to think about. And but yeah, AI kind of came up with some like really good ideas for me because I'm usually going to thesaurus trying to figure stuff out, but AI is a shortcut.
Yeah.
Yeah, I just go to is it openai.com, and then they give you the prompt for ChatGPT. You can just ask it whatever, and it's pretty amazing. Like I wonder how long before what we aspire to do won't mean anything. Hopefully it doesn't. We don't get there.
Yeah, really.
Chip, I got a question on that dot wait method. Could you go back to your interpreter code?
Yeah. Okay. Hold on. Let's see here. There.
So that's it right there. So it says the statement, if no unhalted task, wait for possible interrupt to unhalt. So that means that if there are no running tasks, the only way to get beyond that line is a PASM interrupt.
Yeah, because see, you will not code your spin code to ever get you into this circumstance, but someone might make a thing where he's got all timer based tasks and he's got some PASM interrupt routine that's like it's continuing or unhalting tasks at different times. So in that case, this thing might come in here and go, because this doesn't make any sense. Like nothing's ever going to change, right? But if an interrupt occurs and it cancels some bits in here to reveal the enabled task after the and not, then it will fall through and run that task.
So when you're using this preemptive state machine in a cog, does that mean all tasks in the cog? No, the cog will require only tasks. There's no other code. You mean all the code in one cog using this state machine configuration needs to be a task.
Well, see, the thing is, it treats your main program now as a task, but there's really no functional or time difference. It's just conceptual, right? But now you can add other tasks, and until you do a task next instruction or this thing up here, nothing ever changes. I mean, it doesn't take one more cycle to execute your existing program, but when you do a task next, then it does this context switch where it looks into the task list and it looks at the task enable and task halt bits and goes, okay, what's the next thing that would run in this round robin thing, and it picks it. And because this rotate thing here eventually, like, this eventually just keeps circling and circling, but it's only stopping at the tasks which are both enabled and unhalted. And it just
okay. So let's say in one cog I have 2 tasks, and it's the more code elsewhere. Those 2 tasks are going through this, and I halt both tasks. That cog essentially stops.
Yes. Yeah, okay. And it's gonna get stuck right in here. Now see, right. But it's only even coming into this if there are some enabled tasks. Because if you stop all of your tasks, it will eventually stop the cog. So
Right.
you never even get here. So the fact that it's even getting into this whole routine here is because there is some enabled task, at least one. Whether or
Well,
not,
I'm saying, well, if you use this in a cog, you'll have to have all code related to a task. A task. Each, tasks will be in one cog.
yeah, they're all running in the same cog hardware, but they could be in an object. They could be, you could use a method pointer when you launch a task. You
Well, if
don't
you
need
have two cogs, with tasks, and one cog ends, all the tasks are done and not disabled or halted, that cog essentially is done because
uh
of this code, that wait.
yes. Yeah. But see, this isn't meant to be an infinite loop, right?
No.
Because if
Well,
you ever do get in here, you only would get there because you had something else going on. Like you had some PASM code on timer interrupts or event interrupts that were unhalting or continuing tasks, which would cause this thing to fall through and then go to whatever that next task was.
uh-huh, uh-huh.
So is it making sense, Kevin, is it making sense that tasks add kind of a way to do multiple things in a single cog? And
Yeah. Yeah,
any
it's like a
number of
state
cogs
machine.
could be,
I
yeah.
liken it to a state machine. But
There's another way to think about it too, is that all of our multiprocessors today that are running our big, Linuxes or Windows or something like this, they all have threading. And threads are essentially the same type of thing here.
right.
Yeah, you
Yeah.
could call these tasks threads. Like all threads are running and they're all at different points in their own program counters and where they are in sub methods and everywhere else. But the thing is, they're all running independently. They're just they're time sharing the cog to get
Right.
their work done.
Yeah. If you had a project that had 8 tasks and it would seem that you want each task in each cog. Just
No.
it seemed to me it's more for if you have multi-processing going on, truly, not like a state machine, and you only have 8 and you got a processor that can do 8 concurrent processes, you just stick with the normal, and you would avoid the task type uh
Right.
in one cog.
Yeah, the point of this is like if you want to dedicate cogs to other things like hard real-time processes, because and your spin code doesn't need to take like it doesn't need to run so fast that it couldn't run in a thread or a task as opposed to hogging up a whole cog. This is a way to get the exact same performance minus the timeliness because now you're going to have jitter because each task as it runs is going to take, everyone's
Yeah.
going to take a little bit different time. So by the
Right.
time you get all the way back after you do a task next, it's going to be jittery because everybody else is in ever convolving different states of their own, you
Right.
know. It's
Okay,
just a way
thanks.
to
Yeah.
like get more functionality out of a single cog.
Right. Well, if you just, it's a very, it's like Stephen was saying, this is a solution to that's commonplace in a single threading processor.
Yes.
This is how they adapt to, this is what they call concurrent processing
Oh,
or
this is, yeah,
multi-channel or whatever. It's kind
right,
of, it's still a state machine when you boil it down.
right.
It's okay. Yeah.
Yeah, so we have like real concurrent processing, but we could also do state machine type switching.
Exactly. Yes.
So you could divide up your problem however you want.
Right.
Yeah, Chip, I have a question about it. I'm also very excited about having this. Um, so, one of the things that I needed to do with my web server is basically have several different listening ports open. And I needed to go out and grab, check the port. Is something, has someone connected to it and what is their request? And one of the problems is some of the requests will take longer it will basically cause blocking if I'm only using one cog to do that. Now I can easily, make that work with multiple. Dealing with things like what's on the stack and everything for these individual tasks, whenever it's one of those things to where I can easily set in there, okay, task next. I've completed everything I need to do right now. Let somebody else get a bite at the apple, and it go
That's
around to
right.
the next task. Do I have to do any bookkeeping of like the stack or any of that kind of stuff? Or so it's just like a cog. I mean,
it's just like a
in
cog.
this,
Yeah,
in the sense that you get to choose when the next task runs.
that's right.
Oh, man, that's so cool.
Yeah,
That's
I
so
mean, it
cool.
just, at least I think I can confirm that. Yeah, there's no extra work to do. It doesn't look any different code-wise than if you're running on the whole cog or you're running on a task. The only thing is if you're running on a part of a cog with tasks, you just have to put those tasks next instructions sprinkled in your code so that you're not hogging too much
Yeah.
time.
Cool. Interrupt or something else that arbitrarily is perfect.
Yes. Yeah, you get to cooperative kind of like not very error prone, but if you're getting ability to lock what you're doing, and those can be tricky to work out. Building block kind of thing where it's not going to get out of hand. You're in control. When you're ready for the apple. Okay.
But I guess they're careful to make sure you don't have something that gets stuck because you are relying, which uses like your own timer, if you will. So many ticks per task. So you say, okay, this task gets 1,000 ticks.
Right. Well, a
something.
thousand opportunities in a time frame. Preemptiveness is the statefulness can become huge. Like if you're in the middle of a byte move and you got this buff space in the interpreter filled with data that hasn't been fully moved to its destination yet, that would be like too much context to have to store just to switch tasks.
Oh, right.
It would take a lot of time. So by doing it between instructions for all the states consolidated down to like what become 8 contiguous registers, it's very clean at that point to flip and go to the next guy. I got a rotary switch. Click, 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 as opposed to like having to do a lot of mopping up. And, I don't think there's any less error prone way to do this than putting the programmer in charge of when it happens.
Hey, Chip, before we wrap up this, can you just look at the discussion and answer the last question?
Yeah, let me see here. Let's see. Oh wait, no. Where's the chat thing here? Oh no, I hit the apps button. It wants to loading.
Well, I can read it
Load
to you.
apps. Hold on here. Let's get rid of this. Okay, here we go. Chat. Okay. Oh, there were a lot of things here I didn't notice. Sorry, guys.
Barry, when you have a chance, watch the first hour of the video from today too.
Yeah. But the answer is yes.
Okay, so Ricardo Bosa, he asked, so you can have only max 32 tasks. That means you can have 32 new tasks plus the main tasks used to trigger the 31. That's right. But remember that any of those other 31 can become the main task if that's how you kind of arrange your code. I mean, there's nothing special about the initial task. It doesn't have any special characteristic. It's just one of many. So if you have 5 tasks, any of them can kind of play boss. Doesn't matter. Yeah, 30. There's 32 per cog. I think the task next keyword is the only thing needed to call on the next available task. That's right. You just need to sprinkle task next instructions in everyone's code. If one guy doesn't have a task next and he gets into an infinite loop, the whole show stops because now it's not switching anymore. Let's see. Is the main method that triggers tasks using one of the slot tasks, meaning only 31 new 31 tasks can be triggered plus the main. No, everybody has control. Any task can start another task, stop a task, continue, halt a task, do that to himself. It's just like cogs. They're kind of all peer to peer. Okay, I think those were all those questions, right?
Great. Okay, so Terry's here. Maybe we can talk about Blitzen.
Yes.
Terry.
All right, sure. So if you look over here, this is one of the many light controllers that I have out in my yard running a Christmas display. And it is a 24 port pixel controller. Currently, I only have it configured so that it runs the most popular pixels, which are the WS 2811s, which are ubiquitous. You can get them from everywhere. You can get them on Amazon. If you look here, these 10, $120 on Amazon. And right now I've only got 170 of them lit up. At the moment, it's all my power supply can do. So it's a 2 amp power supply and it's cranking out 1.9 amps right now to run the pixels as well as the light controller. But let me just kind of go through a slide deck real quick. First, I'm going to talk about the my yard display, and then I'll get into more details about the P2 based controller, which I've got links that I'll provide where you can. Whole deal. It's all completely open source. It's MIT licensed. If you want to use my terrible code, please. um, uh, how can I share? Go share and okay, can you guys see that?
Yes.
Okay, awesome. Okay. So 4 feet by 8 feet, and that image on there. For the holiday and images and everything that is shown. I used that actually way back whenever I was just using 13 or 14 of those things out in the yard. They had 16 ports on them, and they were just AC dimming DMX. The newer stuff that I'm running is a combination of Vixen and X lights. So these you put in like your you can create the sequences of telling what lights to turn on, what effects you want on the lights. If you want to sparkle, if you want it to be a rainbow, if you want it to be, whatever, you can do that in both of those pieces of software. The Jinx software is, and all of this is free, by the way. This is all open source free software. The Jinx software is a PC software that is strictly for matrices, so that you can, put real-time live information on there if you want to. You can update it real time. You can have DMX data call certain Jinx sequences, so that you can have Vixen or Xlights call things in Jinx to display out to the controllers. But generally, so like so this is my display. I don't know if you guys can see that or not. So I have about 2.5 acres in the front yard, and this is the two-dimensional view in the top left-hand corner. In the top right-hand corner is the three-dimensional view, where you can see where these things are stacked, in behind each other. I have 200 individual pixels that are scattered out throughout the yard. There is that covers 20,000 square feet. They're 10 feet apart from each other. And it is a single port that runs all of those with a whole lot of power injection throughout the whole thing, so that the 12 volts doesn't drop down and you get all kinds of jittering colors and things like that. The interesting thing about what you can do is the software in Vixen and Xlights allows you to create these 3D models and then put effects across the entire display. So those two images in the bottom right-hand corner there, the top one is obviously a picture that I took. The one down below that is what the sequence looks like in Xlights. And it was putting a candy cane effect across the whole display. Now, the color's a little bit washed out on the photograph, but you can see that it does a pretty good job of mapping that stuff together. I mean, we're not Disney Imagineers or anything, but it's not bad for just free software and putting things out in your yard and taking a little bit of time of organizing it so that you can display it there. It usually takes about I start in September putting this stuff up. It's whenever things start going out. Typically, right around April is whenever I start building whatever new goes in. The new things that I added this year are all of those items that are underneath the arches, and those the round circles, those contain almost 1,000 pixels each. And the trees that are underneath those arches, the tree and star is 400 pixels each on those. So here is a network diagram basically showing how all of this is put together. A Raspberry Pi that I bought from Parallax. You need to get those Raspberry Pis from Parallax if you're going to buy one. Runs everything. So it's a Pi 4 with 8 gig of RAM, and it's pretty much overkill for what I'm doing with it. Whenever you render those sequences, you render them out into files, and the Pi has a piece of software on it called FPP, which is Falcon Player, and you just drag and drop those sequences into a web page on the Pi, and from there you can schedule them and set them up to play. You also have to put the audio out there as well. So connected to the Pi essentially is a small FM broadcast transmitter that doesn't go far beyond my yard. Go in front of the house though, and all of the sequences are synchronized to that. The sequences operate at 40 frames per second. I render them all at 40 frames per second. Everything that I have can easily do that. That means that every 25 milliseconds, it updates the entire display. Entire display is about 30,000 pixels together, and that's just a whole lot of DMX universes. Each pixel requires 3 DMX channels to operate. What the Pi does is it sends the data, which is DMX over Ethernet. The organization that put out the DMX standard also put out CN is the E131 standard that they put up as an ANSI standard. And it's an ANSI standard for doing DMX over Ethernet, and so it sends that data out from the Raspberry Pi to all the individual controllers. The Raspberry Pi knows what each of the controllers are. It knows what universes and DMX channels, are associated with those. So it just goes out to a layer 3 switch that I have. It's a managed switch, so I can set the speed and duplex and do packet shaping and all of that. I set all the ports to 10 megabits full for these because the WizNet controller that I use, the Ethernet controller, can't drink from the fire hose very good with UDP packets at 100 megabits per second, and you can't get packets out of it fast enough before it runs out of buffer space. So using it at 10 megabits full, you get just perfect non-jittery displays. So this is a representation of each of the controllers that I have. Plugged into that layer 3 switch, it's a 24-port switch that I have out in the front yard. I have an access point for Wi-Fi, and I have each of these 8 controllers, or 9 controllers, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, the 9 controllers plugged in via hardwire. So they're all plugged into that switch. It is gigabit between the switch and the Raspberry Pi. So you can send. It's much more than 10 megabits per second that goes out to all of the controllers, but each controller only drinks from the fire hose at 10 megabits. I have the one over there on the right, which is wireless, and that runs my fence. So I have 500 feet of fence that has those small pixel seed LEDs that I was just showing on it. And it's 500 feet of it. It's thousands of pixels that are on that thing. They're 4 inches apart, but they almost look like a straight line whenever you view it from a distance. And even going across the Wi-Fi, it looks good. You don't see a lot. You don't see any stuttering or dropping of the data or anything like that. I only use 2 ports on that controller. I just have one. Basically, I put the controller in the middle. I have one that faces east, one and another string that goes west. And in the software, it just sees it as a single string, and you just patch it back together on the software side and group it together. And you drop your effects on there, and it will make it run all the way down the fence and all the way back. And you can't tell that there's a difference. That it's split apart or anything like that. The one controller that I do have that has all ports used is the Mega Tree, and it has 24 strands of lights around it. It's 10 feet tall, and the lights that are on it are 1 inch apart. So there's 120 on the strands coming down. Then it has a star up top, and so that really it's kind of wild because even though this thing's 10 feet tall, whenever you stand beside it, it looks huge. Whenever you get out to the road, it's like, oh, there's a little tree over there in the distance. Oh, look, we now have Alvin and the Chipmunks on the tree, and so that's those are the kinds of things that I wind up doing with it, where you have Alvin and the Chipmunks sing, they'll be on the tree, uh, you know, uh, fun stuff like that. Um, let's see here. Yeah, I have. I think I just went over that. I have 10 of the Blitzens out in the yard. I forgot to put together what these look like in the enclosures. The enclosures that I've been using lately, and they've just worked out so well, um, are the large ammo cases from Harbor Freight. So like there's like a 50 cal that works really well, and then there's one for larger ammunition that they sell. They're like $20, and you can place a power supply in the bottom of those things. You put a piece of HDPE over that with some standoffs. Um, and then you can mount your controller board over the top of that. There are fans in there, and these things they're dark colored, they're black or they're very dark green. I've had them out there, since September. We had over 90-degree days, and uh, with these things, and I haven't had any thermal problems with them. I guess even though black does tend to absorb and re-radiate, it also re-radiates the other way. And so with most of them being on the ground and the power supply being right there on the bottom with the fan facing up, I would imagine there's probably a little bit of thermal transfer that happens there. Being in the South, the ants love those things. So I now have ant mounds around the bottom of these things that have been sitting out there for a few months.
Why do the ants like them?
I don't know. But I know that I'm going to probably put some Seven Dust or something underneath them for next year.
Is it maybe a little bit of heat or something that attracts them?
Yeah, it could be. It could be the heat, because I didn't have that until it turned cold. And then once it turned cold, those guys, I started seeing dirt come up around them. I'm like, what is that? I went and picked one up, and it was just
Yeah,
ants everywhere.
probably boosts their metabolism.
It could. I don't know. I hope I'm not breeding some kind of super ant. This, this is the last thing we need. Um, so here's some pictures of the yard. You can see the full yard in the top left hand corner. That's just a screen grab that I did with one of the sequences. The items on the right, I can't give you a sense of scale with that. So the white line that you see in the background, that's just part of the fence. And each of the LEDs are 4 inches apart on that, and it's 500 feet of that. These arches that you see in that display, each of those have 300 LEDs in them. It's you can only control 3 of them at a time, in the sense that that creates 1 pixel. You can't do all 300 individually. You can only control 100 of them. But those are.
Is that because of power limitations?
No, that's just the way that they happen to do their strips that you buy. So the arch is made out of PEX. So I use PEX as a diffuser, and I just take regular LED strips that you buy that are they're like 15, 16 feet long, and put them inside of that. And it protects them from the weather. I haven't had any failures, and they're not exposed to any of the weather or anything. And those also are ones that are supposed to be weatherproof, so they've been fairly durable with that. But
Do you like silicone the ends or something so that you make it kind of airtight?
what I wound up doing is I wound up putting PVC ends on them.
Oh.
And I have holes drilled in it where it has an input and an output. And I was doing power injection on the back. I have it from the input and stay bright all the way through. And typically you don't have to do that. A lot of times with these DC pixels, as you go down the strand, you'll get a voltage drop, and so the end light isn't as bright as the first one. That's not something you have to worry about too much, because most of the sequences are they
Low,
don't turn it. Yeah, they don't turn everything on at once.
yeah, low duty.
Yeah, exactly, exactly. Um, but yeah, so the wagon wheel that you see there, that thing's 48 inches tall. Um, the top of that arch is about 5 feet. Um, the uh, the square display you see in there, that's 4 feet by 8 feet and has like 3,500 pixels in it. So for each of the items that I have uh, on each side of where we have arches and those 1,000 pixels and the trees right there up front, a controller runs one set of those. A controller runs the matrix in the middle, and then we have another controller that runs the things over on the right. And the thing about it is, one controller could run all of that with no problem, except the amount of power that's drawn and the distance that's required between those things, because that's over 100 feet. It's like 120 feet tip to tip across the display right there. And the voltage drop will get you with a long run. You also get capacitance on the wires, which misshape the data that goes to these pixels, and it doesn't take much at all to make them where they start displaying garbage, or they'll start having a one-off, or they'll just glitch, and you'll get all kinds of fun artifacts in the forums for like Xlight and Vix, and you see all kinds of people having problems with that stuff just simply because they try to run everything off a single controller, and they have things ran all through the yard, and it's difficult to make it work. If you can distribute it out, it solves a lot of problems. But yeah, I mean, it's just whenever you watch any of the videos or anything that's associated with you don't really have a sense of scale with that. Um, that bottom picture shows like uh, the lawn lights that I have out there with the individual pixels. You'll see the things up in the tree there. Um, those are actually 13-inch lamps that I got from Home Depot. Put 9 pixels in each of those, and can control these large light bulbs like that. And of course, they look like these tiny little things whenever you're whenever you're looking at them in a picture. But yeah, I mean, it's about 30,000 pixels, and October turns into just testing to make sure everything works. And so I do like a week-long Halloween show with a couple of different sequences and everything, and then it shuts off until Thanksgiving. And I hope nothing messes up. And luckily, the past few years, no problems in between. I keep all the controllers up and running, and they just sit out there and they run for months on end. You don't have to reboot. You don't have to reset. That is something that actually started this whole thing. The reason why I built a P2 Lite controller is I bought a very expensive, reputable, controller, and I'd have to reboot it every 8, 9, 10 days, and I don't want to deal with that. I'm like, okay, how hard is it to do this? So it took a year or so of nights and weekends to actually get something that's workable, and gone through a couple of iterations of that. But the one problem I tried to solve, which is I don't have to reboot it, I did solve first try out of the gate. I haven't had reboot problems, so that's been nice. Um, let's see here. So this is kind of how it all started, with the Johnny Mac board. Um, on the kitchen table there. Um, so I'll just go ahead and talk through, kind of how we're using it. I've got one cog that's dedicated to reading the Ethernet port that is configured for the E131. You got to get that data out of there fast, and you got to get it out of there faster than anything else you do. That's the part that will give you the most lag, is getting data out of that Ethernet port for the UDP data. And so I have a dedicated cog to doing that. I wrote it in a way that whenever that cog starts, the pixel configurations are actually written to LUT RAM. So I'm using it as a lookup table. I'm actually using LUT for LUT. Um, you have that nice fast RAM right there, and it allows it to go through and go, oh, this goes to this universe. That's this pixel over here. So it jumps over and immediately starts writing into hub RAM for the data that it recognizes should go to that universe. So there's a table that's in memory that whenever that table gets updated, you have to restart that cog so that it rereads it. So it copies it out of hub RAM and into the uh, into the LUT for that one cog. So one cog is being utilized for that. I have 3 other cogs that are used for running the pixels, and I think I can get away with a lot more than that. I think I could probably run that just with those WS it's both WS 2811 WS 800 kilohertz. But I have another cog dedicated to the next state, another cog dedicated to the next state. Thus, we got a 24 port controller. So this is the other thing, kind of showing how the pixels are put together. So you can only have 170 pixels in a DMX universe. And the reason for that is they take 3 channels, and the 512 isn't evenly divisible. So you wind up with a couple of channels out there that you can't use. So typically 170 is what everyone uses for the number of pixels you use inside of a universe. And you can see I have universe 400, 401, 402, 403 configured on the output. This is on my fence. So that's the westward facing output right there. That's on port 1. And you go into the web browser and you configure all of that through the web browser. You don't have to fool with any config files or compile it special or anything like that. You go in there, you set what universe you want, how many pixels you want, you save it, and it writes it to the SD card. You don't have to fool with that again. Let's see here, and yeah, so you have many DMX universes that wind up getting mapped to these things. Here's just some performance things in here. You can do 2 full universes. It'll receive 2 full universes in a millisecond. So 20 frames per second, you can do 17,000 pixels. Each universe, being 170 pixels. Controller on the display, then 20 frames per second. Some of the things on the matrix just look amazing at the 40 frames per second frame rate. But you can see every time this goes low, that's whenever a new full universe is coming in. I even have it configured. If you'll notice on the last slide that I showed, we had a short universe, so not all pixels were being used in the universe, and I use that as a cheat where if you have a short universe and you configure it that way, once it reads up to the point that it gets all the pixel data it needs out of that packet, it stops reading. It resets the buffer in the chip to say, yeah, I've read all of that, and sets up it acts as if it actually read that data. It didn't read that data, and it moves on to whatever, waiting for the next packet to come in. And you can kind of see the number of universes come in versus an entire universe of data going out to the pixels. That's what that looks like, as opposed to individual universes coming in. So I have a cheat. I'm trying to make this thing just run as quickly as we can whenever it's running. So I'll provide some links. I'll post these in a comment when this goes up on YouTube. I'll try to put those here in the chat as well, where my software is for the Blitzen 24. The breakout board that I use on these for the WizNet. I also wound up building a board that goes on the that works with all of the edge components. And there's a number of people that have gotten these from me. So if you have one of those, you can actually load the software up on those and utilize that board the way it is without any no code changes or anything. You just drop the bootable SD card on the on your edge, put that on the right pins, and you've got Ethernet up and running. See here. So yeah, I talked about Vixen, Xlights, and the developer bundles. What I believe I started this project with is using the developer bundle from Parallax. Let's see here. I have no idea how to stop sharing this thing. I'll show you guys like the latest iteration here, which is the second version of this. Let me see if I can figure out how I swap this around. And there we go. Okay, so yeah, here's the spool of wow, these are actually really warm right now of pixels, and this is the light controller. The controller itself is fairly basic. We got our Ethernet. We have our regulator circuit here. I did something special with the regulator circuit so that whenever you press reset, it power cycles everything on the board. And that was helpful with a lot of the items or a lot of these controllers because whenever you would hit reset, it would come up in a state where you couldn't boot the P2 from the SD card. And power cycling everything solved that problem for most of them. Some of them had trouble booting without having reset pressed, and I have since found that that's actually because I have some really cheap SD cards that got into the bunch. And not all SD cards are the same. I've found that using the SanDisk Ultra Pluses work great. 32 gig SanDisk Ultra Plus, no problems with those guys. That I was with the DD and these guys. I added this little it meant it will the nice thing about adding the knob is I now have multiple screens that I can show. So like there is the screen that just gives you the IP address and the status. It tells you how many decodes are happening. I have one right here that gives a QR code so that you can just scan that with your phone. If I'm out in the yard, I can just click it over to that, scan it with the phone, and pull up the configuration page on my phone, make adjustments real time. And the other item that I have there, the other menu that I have on there, basically shows you the version of the software that you're running. I did call the latest version of it Rockland, and the It gives you the uptime on the system. So that right there is showing it's been up for 19 hours and 29 minutes. And it also gives you the speed and duplex of the Ethernet interface. I have that one set to 10 full. The outputs are buffered. Probably don't need this in most situations, but I wanted to make sure that we had 5 volts going to the pixels, which is what they specify is needing for an input. And so that's the only reason those are there. They did save me from a lightning strike once. I did have a large lightning strike. I live in the South. We get storms all the time. I have one of these permanently mounted on my house. Had a close by lightning strike that took out my switch. It took out my cable modem. It took out a charger out of my garage. It took out another switch in my garage. Um, and it blew up those buffers right there, but did not blow up the P2 until the next week, whenever another storm came through and it took out pixels that were on the house, and it caused some problems with that. I found out the problem was where I had a new driveway, concrete driveway poured. They disconnected my ground to my cable modem, and so that wound up causing all of those problems. So I haven't had any of those problems since. But I was surprised to see, man, the P2 took that first lightning hit like a champ. The second one, it didn't have a chance though, because it literally blew the casing off the top of the thing, and there were chunks missing out of the P2. There's no way that you could get around that. uh, but it did great. One thing also in here, I have quad DMX that comes out of here. So you can run 4 DMX universes right out of there, and directly drive things like moving heads, or like older AC dimming controllers, which I had in the show last year, but this year basically got rid of all of my 110 volt things. It's all low voltage. Um, Other things that are nice about the newer version is I added these higher current power connections, and I wound up finding some correct fuse holders down here that actually have the insulation that goes around the fuse holders. So that's been fun. But I started on this project in 2021 and just gradually added more and more things, both software wise and hardware wise, over the past few years. So that's just kind of an overview of it. Does anybody have any questions about anything?
Something that I
those,
heard. Oh, go ahead.
yeah, the question is, your Blitzens out in the field that are wired, are you using direct burial like Cat 6?
Oh, no, 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 no. So there's a single Ethernet cable that goes out. It goes about 250 feet out to the center of the yard, and that's also where I centralize the power. So I have like a 220 volt outlet on the side of the house, and I run um, uh, basically it's service entrance cable out to this large box in the yard that has a circuit breaker in it, and then has a number of 110 outlets in there. So all of that stuff's about 250 feet from the house.
So your Ethernet goes out to that box, and then you have the switch out there,
Yeah. Mhm.
the TP link. Okay,
Yep.
nice.
And,
And then
and
in each Blitzens, the Cat 5 enters through a watertight like bulkhead fitting
it
in the
does.
plastic box. Okay.
Yeah, yeah. Let's see here. I'm trying to think. Let me grab those real quick. I'll show you what those look like. Yeah, so and that's pretty much the same thing that I use for the Ethernet is also what I use for the cables, and they are these guys right here. What are they called?
Uh-huh.
PG7s.
Okay.
And you get a
Nice.
bag. You get a bag of these on Amazon, and they have a rubber
Mhm.
thing in there, and as you close it, it collapses down and makes it a watertight seal. And I will knock on wood. Fortunately, I've never had any issues with water intrusion. Um, so that it works out pretty good with those types of things. I'm looking around to see if I have any of the connectors that I use, and of course I don't have any laying around here. I've used them all. Um, for the connectors that come out. So I'll have connectors that plug into each of these, and they'll go through the PG sevens, and then you have a connector that kind of looks like this right here for each of the items. These are called X connects, and they're available on Amazon or any of like the holiday lighting controller guys. It's sort of a standard, non-standard item that someone come up with, and they're just simply called X Connect. So, Chip, you had a question.
Yeah, well, weeds are a big part of my life. So I was looking at that big yard of yours and I was thinking, before you set this up each year, you must give that thing a really close mowing. And then you hope that through the winter, you don't get weeds growing through everything.
Yeah, so luckily I don't get a lot of growth in the wintertime. Um, it's even the parts that aren't shaded, kind of lucky with that. Um, but yeah, that's always a point of contention of when are we going to have the last mow? And that yard's so big, I have a guy that comes out and does it for me just because uh, I can't afford to repair my mower that much. It's
Oh,
it's a
yeah.
beast.
Yeah, that's a lot of area. And once those lights are out, you really can't do anything.
Yeah. We um, had a guy that was going to come prune the trees last year, and then he waited and he waited, and it was one of those things like, look, I'm sorry, we're gonna have to cancel with you because we got to put lights out.
Yeah.
And because once that stuff goes up, it's always a thing where I have to let the kids know, okay, guys, you can't go run through the yard, particularly with all of those lawn lights that are out there. It's a huge trip hazard. It's like, do
Yeah.
not go into the front yard.
Yeah, right. Right.
Nicely
Any,
done, Terry. Thanks for
yeah,
sharing all this again.
Yeah.
sure,
We'll
I
do
have
it
a
again
quick
next year.
question for you, Terry.
yeah,
Did I hear Ken say earlier that you live in Tennessee?
I do.
Where?
I live in Mount Juliet.
No kidding.
Yep.
I live right next door to you in Hermitage.
Oh, you are next door. Oh my goodness. Yeah. You're in the 37027, aren't you?
Two
Or
six,
626. Okay, yeah.
whatever it is.
Yeah, you're right there.
Yeah.
That's great. Well, we'll have to meet up sometime.
All right.
Um,
I'd love to do that.
yeah, if you want to come by and see the display, send me a message on the forums or whatever, and I'll be
Okay.
happy to show you around.
Yeah, I'd like to see it. I'd like to
Absolutely.
see it. So yeah, we'll get in contact and I'll drop by and see it. I'd love to.
Perfect.
It looks good, by the way. That's
Oh,
great. I love it.
thank you. And I'll drop some links, by the way, for you guys in the chat so that you can kind of see what some of the videos look like.
Adding on to what you've got, Terry, I just want to show a picture of something we are releasing tomorrow or Friday. So if interested in light control, like you've seen from Terry, we have a holiday pack of these parts, which is coming out, looks like tomorrow or Friday. And it consists of a Wi-Fi module, an OLED display, a flip, reset button, and a couple of push buttons. I guess those are really 5-position switches and a speaker. And then behind it is a 16-foot WS2811. So with this kit, you can get a feel for controlling these. You'll set it up just by configuring your wireless access point on that OLED, and then you'll have wireless programming. And we're providing the spin code for this. So you'll be able to select different programs and see some example code, which probably uses some Johnny Max drivers to control the LED. And you can control this wirelessly. So expect to see this from us probably by Friday morning. And I think we made about 100 of them. Not sure if all that came through because my internet's so spotty right now.
Yeah, it's been kind of choppy. You've been going in and out.
Yeah, did you hear most of what I said?
Yep.
Okay, cool. So yeah, something to do when certain relatives come over and you need to retreat to your lab. Okay, so we are open. We can handle other questions here or support issues for whatever's on people's minds.
Chip, I had a quick question for you. With all your task switching and task capabilities, is this laying the groundwork for a P3?
No, well, a P3 would be like $1 million effort because, that'd be another silicon turn. No, this is all kind of in view of making something like, here's the thing. Look at us, right? And I'm not even that good. Now, Stephen Morocco knows all about how to find his way through modern things. I kind of have an aversion to it. Even installing like some giant app on my computer is a pain because it's big and it's a mess. So I'm thinking there are a lot of people out there that they don't even, I know some things, right? But not everything new. But even just loading giant apps and installing big things on your computer is a pain these days. So I want to make something that's really easy to use, that doesn't involve, it bypasses the entire modern computer mess. So you think about the pyramid, right? Here's all the people in the world. Okay, we're kind of near the top of the pyramid, right? We know our way around these things. We can deal with complexity, but there's this band of the pyramid down here that doesn't know about any of the stuff, but might like to do these kinds of things. So I'm thinking, like, what kind of computer would those people need? They might want to switch like 120-volt things off and on. Like where I am, there's a lot of these guys that they're big into growing like marijuana and stuff, which I'm not into, but this is what these guys do. There's a lot of these people. Now, these guys would like some kind of way to design something to do like for their grow rooms or whatever, but they're not so savvy, and they don't have the presence of mind and maybe to do all these really complicated things like we try to do. But if there was something for all these people that aren't so versed in this stuff that could get them in quickly, like if they could have something they could plug into their TV, plug a keyboard, a monitor in, have some kind of graphical programming environment where they kind of like compose what amounts to code, but in a way a person thinks, not like how a programmer has to think. Something really natural. That's why I wanted this task thing, because there's going to be a need for lots of they're going to think about things in terms of little pieces of things, like wait for a time, then turn a light on or do something. And so I'm thinking that a good product for the future would be something that allows people to build systems and circumvents the entire modern, virus hysterical computers. I mean, the other day I even posted a new version when I put out Peanut V47. It's like their virus alarm went off and they couldn't even run it. I can't even give code reliably to people anymore, even though we all own our computers. So we need something to just get out of that entire system and enable people who don't want to deal with that, or are ill-inclined to deal with that complexity, still the ability to make things.
Yeah, you almost need like a kind of like a flow charting tool. People can
Yes.
just draw things logically. This is what I need to do. Just tell me how I
Yeah.
can implement that somehow.
Yeah. Have you ever seen block programming?
Yeah, it's pretty much, I guess, yeah,
Yeah.
pretty
The
similar.
thing,
Yeah.
what block programming does, it creates a reversal of how you have to think. Because like if we program it, let's say we make a language like spin, right? Well, you have to know the keywords and you have to have a mental model of what those keywords do and how you compose them together. But like graphical languages reverse everything so that you see in front of your face everything that can be done, and then they only fit together certain ways. So the guy can't build a program that won't work. Plus, if it's highly graphical, it's got to be like Candy Crush or something, where it's like all the state is visible at all times. So he's seeing his program run without the need of a debugger. Like he's not going to go, well, I think something back there must have tripped something that caused this. That's like too complicated, right? It needs to be in a person's face. They can see all the phenomena at once. They can see the state of everything because it's all graphical. Then it's like super obvious. There's nothing hidden.
It's basically an ASM chart. You're basically building an ASM chart at that point.
What is it called? An ASM?
Yeah, ASM. It's like a finite state machine chart or something.
Yeah. And so and it shows
Algorithmic state machine.
it's like living code. As it's running, you're seeing your code, but you're also seeing, like, if that task is running, if it's not, it'll be like darkened. If it's active, it'll be lit up and you'll see things changing within it as it's working. So everything's
nice.
like always available. You don't have to have mental model of hidden things. It's all in your face. So that would enable people to do better because they don't need to have the complex mental model, which takes a long time and an investment to develop.
Are you thinking this is something that would run alongside Spin? Like as you're programming, you would also have this next to you and it like talks to it in a way?
Yeah, that would be kind of like the first thing is, yeah, it's like a layer above Spin. I mean, the spin would be like what could be under the hood, or I could just write like completely unique code to make it happen. It might be faster that way, but I just had this notion that we need tasks because tasks let you reorganize your problems and make some things a lot easier to solve. Like imagine in a PLC, you only want this one thing to happen under this complex sequence of circumstances with little trip points along the way. And then you get into this one case where you do something unique. Well, it's a lot easier to write that as a couple of code with some nested ifs, so if you get all the way in there, you do it rather than keeping track of a bunch of state information. So we just try to like make it conducive to the way people are going to think and then present it to their face. So there's nothing hidden. Even when it's running, they see it all happening. So if the guy has like a switch out here and he's flipping it, he'll see his program reacting, he'll see it actually happen in real time. Then you can learn really quickly.
Yeah.
Without any, setting up any special debugs or anything. It just needs to be like in your face. Mental model's not necessary because you're always looking at it. So I think that's the way. So, it'd be nice to sell a lot of P2 chips, right? But we're like up at the very tip of the pyramid here. We got to try to get this bigger band down below.
Yeah, your TAM or your total addressable market should be much bigger. Yeah, it's basically the people who are using Arduino and Adafruit stuff. That's the big TAM.
Yes. Yeah. I mean, right now we're in a very esoteric place. Certain people understand this and like it, but others have no idea and they don't know if they would. I mean, they would have value for them, but there's no way for them to get there.
I'm almost thinking because you have your whole data sheet and documentation on Google Docs, like it could be really interesting. I don't know if I've seen this for the embedded world, but having an AI you can almost talk to that's kind of trained specifically on that to be like, hey, look, just talk to me as if I was an experienced engineer. And then that experienced engineer is like, yeah, just walking you through like, okay, this is what you should do now.
Yeah, that's how things are going to be done. I haven't really absorbed yet, like what role AI can play, but I think ultimately that's going to be how things will work. It'll be setting up applications.
Like, because I actually fed like an STM32 datasheet to OpenAI, and I was able to ask it like, hey, I want to do this via SPI. What registers do I have to set up? Like, it knows exactly what to do. So if you did something comparable with Spin and the Propeller, then it can kind of ease that burden of like, okay, I don't know what to do. Let me just ask it, and then it'll tell me, especially because a lot of it's really low level compared to Arduino.
Yes.
You have to.
Nick, have you played with Perplexity?
Yeah, is that like Claude AI?
I don't know what AI it's using behind, but the net result is you can tell it the context. Most AIs, you can set up a search context, and
Oh, I
that
see.
for all questions use this context, and you can point it to the Google Docs as your context, and then you can start asking questions, and you'll be amazed at how rich the answers can be with
Oh, that's
respect
great.
to actually knowing Spin 2. Also, I use what's it called? Chat GP? No, what is it? GitHub's
Oh, the Copilot thing.
Copilot. Yes.
Yeah,
When I'm writing Spin 2, Copilot is getting really good after seeing most of my code for a while at answering and predicting what Spin 2 I want to be writing. And so I
that's
am
pretty nice.
I am seeing good, strong assists from both of those tools. The Perplexity, I can ask it, I can say, hey, I'm working on an iPad app, I'm in Swift, answer, how do I do this with Bluetooth and Swift, because that can be a mess. How do I destructure some of the characteristics coming across? And it'll write all that code for you. It's crazy. Of course,
Wow.
as a user of that code, you still have to be aware of what it will do, what it did correctly and what it
Yeah.
didn't. What's your style? But it's taken you 80-90% there on these things, which is stunning. I moved to a lot of different processors, playing with Cortex stuff, playing with Bluetooth, playing with PICs, playing with you name it, Arduinos, everything else. And I've been finding that when I've left a domain for a while, of course, it's not in the head anymore. And when I need to go back and ask something quickly, it's pretty good at finding things and getting me back in. Moving between TypeScript, moving between C++, moving between Objective-C, Swift, it all just happens naturally with
Mm.
those environments. I'm real careful to set the context for the request, for the queries, to be narrowing. I can use URLs to narrow it. I can point it to documents. I can point it to websites. And that really does help.
Yeah, it's awesome.
So try it. You'll be surprised.
I wish I knew where things were going to go with all this AI stuff, because it might be like futile. I mean, AI might just be able to compose code based on conversations with people who want to build something without the need for necessarily simpler tools. I don't know what the future is going to be. It's kind of hard to say.
Yeah, and I think the safer bet is to use AI to help people understand whatever you're building or the product at least, and then you can at least have it guide them, but don't use it for code generation, I would say. Just help them to decipher things more efficiently, potentially. I think maybe in terms of like using it for your stuff, um, might be better.
I thought
Uh,
of running, I didn't, when I was last playing with Chat GPT, it was anyway, I couldn't really upload our data sheet, but I'd like to do that so that I could then kind of test it to see if it can, if there, is there, should show me where the holes are in our documentation, right? If I give
yeah,
it
that's
the
true.
and ask it to do something and it can't do it, then I know that my documentation is lacking in
That's a
some
good
way.
point. Yeah, that's a good point. I also noticed too when doing the low level stuff, especially with assembly, I have such a hard time of visualizing the registers and like when you're manipulating bits, it's such a hard thing to keep in your mind. I feel like having a program or a piece of software that just like visually as you wrote your assembly, it would show you a visual like, okay, this is what it's actually doing in this register, like highlighting colors or something just to easily see real quick, okay, what is this
Oh
command doing?
yeah. Anything to like hasten the development of the mental model or make it so that you don't even really need it. Like I have these big monitors on my desk that are in portrait mode. And so I can see like hundreds of lines of code at once. So most all of my routines that I'm working on, I can see from beginning to end, which is super because it relaxes my brain. And I haven't needed to print anything in, I don't know, 5, 6, 10 years. I don't even care about printers anymore because my
Oh
screen's
yeah.
sufficient for everything because it lets me see enough. So the more you can see the, about what's happening, the less you have to remember and the more easy it
Right.
is to work on.
And you guys do have like do you guys have training academies or I guess just like introductory kits and stuff?
Yeah, we have, I don't know how, mean, we do this for our educational products because we have to train teachers on how to use that, but that's relatively simple stuff, you know. What you can do with a microcontroller is super open-ended, and everybody has something different they want to do. So we don't really have anything like that, but
Well, we certainly do for education.
for education we
Yeah,
do, yeah.
we train hands-on about 300 to 500 teachers per year on
Oh,
programming
that's really good.
our kits. Yeah, I just put a link to those classes that we run. We send them hardware, and then they come in live for a hands-on event, and we also go to sites to do it. But it's much more basic than what we're talking about here.
You know, Chip, back to what you were just saying about your large screen monitors, obviates your need for printing anymore. That's a very good example of how just a simple change in your own environment can make things easier for yourself. And that's a great example of how that happens, how that comes about. You know, years ago, nobody had multiple monitors.
Right.
Everybody's got them.
Yeah.
I've had up to 3. I have 2 right now, but the large screen monitors, you know, do make a difference.
Yeah. Look, I'll take my little camera here and I can aim it at my monitor, but look how much code I can see all at once. You know?
Yeah, you got it all covered there.
Yep.
Yeah. I would think, you know, our discussion here about with AI and your mindset about how you don't necessarily want to generate code from AI. You want to generate something new to let people see things, multiple things going on at the same time. And big screens, having multiple screens is just part of that. But the other part is when you're shifting your mindset, which is what you're talking about, when you're shifting your mindset, that brings up a whole new set of issues or problems, because really what we're all doing is problem solving.
Yeah.
You know, when you think
Yeah, that's the problem. When AI generates code for people, they still won't learn it.
yeah, exactly. But do you have to? If AI gets really, really good at computer language, you know, now, but with AI and generating software itself, not just code, but software. Nice.
Well, also, Chip, have you guys thought of, I mean, what was the starting price for the Propeller 2? Is it like $20 for just the IC or 16?
It's something like that. Yeah. And the modules are like,
Yeah.
I mean, we have some margin on our modules. Is Ken still here? Ken, you're here.
Yeah.
So what do we sell a P2 Edge for now?
I think I need to check.
It's not cheap. And I think our build cost is like $22. And I think we sell it for like 59.
No, a P2 Edge is $79.
That's not even the 32 megabyte one, right?
No.
So it's like very expensive. I mean, we could if you know, it's silly. We sell lots of Raspberry Pis and microbits, and our margins on those are like nothing. We could, if the volume was there, we could make lower margins on these P2 edges. So 79, I mean, that's a lot of money. And I think our build cost is like, it's not nothing. It's not cheap like an Arduino or even a Raspberry Pi. I mean, it costs us as even with our own pick and place line and everything, it costs us as much to make a P2 edge as like a Raspberry Pi sells for? I don't know, what does a Pi sell for? You get something for 20 bucks, right?
And I guess I'm just thinking from like an industrial point of view. Like I know the company I'm working with, like they just use ESP32s just because they have to. It's just there's no margin and they have to be really competitive. So I was thinking like, well, man, if only there was like a four-core propeller or something, maybe less feature rich to help bring that cost down to where it's like, okay, now we can justify using it. Um, but I don't know
Yeah,
what your thoughts are on like, okay, how can we create a better economic line potentially for more consumer products where I guess for industrial things, I guess is a bad example because you can afford an $18 processor, but certain things where it's like, okay, I can't really go over $5 for an IC. It just won't fit. Um,
right.